Okay, class, let's talk about transport. So first let's talk about simple diffusion. Okay, when you go for a passive transport, when you go from high to low, if you've got a container, with the divider, and let's say it's permeable, and you've got a higher concentration water to a lower concentration water, it will eventually just move from high to low. Okay? So now in facilitated diffusion, okay, you usually need like a protein to help pass from a high to low. But now if you're talking about something like active transport, a good rule of thumb to think about active transport is anytime you hear the word active, that equals energy. Okay, so you need fuel, and usually in the form of ATP, adenosine triphosphate. And when you actually use energy, it actually breaks off a phosphate molecule and it generates a ton of energy. That's besides the point. You just need to know fuel and energy, ATP. And so a good example would be sodium potassium pump. Okay, because in the grand scheme of things, okay, you have to understand gating channels. Hold on. Let's see here. 1, 2, here. So here, you've got 3 sodium to 2 potassium. You don't need to know that. You just have to understand that, usually what is happening is that, okay, inside the cell, potassium is usually inside the cell, sodium is usually outside of the cell. So what happens is that when you have a channel, you have to be able to pump. Like this actually determines the resting membrane potential, or the electrical charge to which it governs a lot of movement. And so what happens is that, okay, if you've got enough sodium rushing in, okay, to fit your 3 channels, then it changes shape. And then what happens is that now, okay, so here's your 3 sodium, and here is your potassium. Like, I know it's going to be in your head, but the idea, just stay with me for a second, is that if the right electrolytes, okay, move in and out, okay, it starts to change the charge. Okay, the flows, remember, the flow of ions change the charge. And what happens is that, okay, but this is not something that you could just do like diffusion. It actually requires energy for them to pump, sodium and potassium in and out of the cell. And every time you pump them in and out of the cell, it changes the shape, because now it opens up this door and closes this door. And when the reverse happens, it will reverse back into its shape. Okay, again, the idea is that, okay, channels in cells don't just open and close for everything. It's selective for a reason. The electrolytes are where they are for a reason. That's really like the bigger piece for you to understand. There's also, calcium transporter, there's other transport, but the idea is that active transport will change the shape to create channels to open and close against a gradient. So in other words, now when you use active transport, that means you are moving from a low to a high gradient. You're forcing against the gradient of passive diffusion. Now you need active transport. So I hope that makes sense to you. Now some of the other ones to think about, I'm just looking at the snippets of notes that you need. Oh, you've got voltage gated channels, mechanically gated channels, ligand gated channels, and leak channels. And I think that here, to make it simple, voltage is regulated by, ions and voltage. That's like the resting membrane potential. Okay, number 2, mechanical. So again, sorry, backtrack on voltage gated. Just remember that in the membrane potential, there's a particular charge. It's usually a negative charge inside the cell. So again, when you make it more positive or negative, the gates will open or close depending on, you know, where it's at. Is it more positive? Is it more negative? So if you're talking about something mechanical, it's usually due to stretch. Okay, so again, if you think mechanical, you're actually doing something. So the cytoskeleton is usually attached to certain cells and certain channels. So when you actually stretch them, just by the mechanical action of stretching, it actually changes the shape and allows gates to open and close. Ligand and leak. Leak is open all the time. So they're just things that allow things to move in and out of the cell regardless, okay? Mechanical, I'm sorry, ligand is neurotransmitters, okay? Neurotransmitters, so meaning, like when the body or cell senses a chemical change, then it opens the door or opens the gate. So a good example for ligand is, I want you to think about lock and key. You know, kind of like, okay, let me see, psychotropics, like, okay, serotonin, insulin, right? So when, let's say here, you know what, now I gotta make something up here, okay? Let's say that, okay, I'm making this up, okay? Let's say here is like the receptor, and let's say here is the chemical, right? Let's say this is insulin or serotonin. Think about the lock and key phenomenon. When the right chemical actually fits the receptor, and the body senses now, you know, a chemical change, okay? Now it fits, it opens, it now then fits together, it creates an effect where it actually signals the cells. They say, hey, this is a chemical that fits our door. We're going to open the door. And then the gate opens. Okay, then this concludes the recording for Snippet for Transport. Thank you.